Today we are going to discuss Linux operating system and the shell, the powerful tool that it provides. So let's start. What is the Unix? The history of Unix begins at AT&T Bell Labs in the late 1960s, with a small team of programmers looking to write a multitasking, multi-user operating system for the PDP-7 minicomputer. Two of the most notable members of this team at the Bell Labs research facility were Ken Thompson and Dennis Ritchie. Through the late 1970s and 80s, Unix became the root of a family tree that expanded across research, academia, and a growing commercial Unix operating system business. Unix wasn't open source software, and the Unix source code was licensable via agreements with its owner, AT&T. Several years later, Linux entered the scene. What we call the Linux operating system today is really the combination of two efforts from the early 1990s. It is the combination of GNU software and the kernel developed by Linus Torvalds. The thing I encourage you to understand that Linux inherits those great things introduced in Unix in 1970s. So let's start our discussion on why Linux. If you are aiming to become a developer or researcher in computer science, you are very likely must to start exploring Unix-like operating systems. So, every Android device is Linux under the hood. Cloud computing, websites, video streaming services, or virtual machine instances served by Linux. For example, Google Cloud Solutions, IBM Cloud Solutions, AWS. The next group of Linux-driven devices is IoT devices, for example, smart home, etc. Supercomputers, most of all, are run by Linux too. On the next slide, here, we can see the distribution of operating systems on supercomputers. Before 21st century has come, most of supercomputers were run Unix. And after we see the growth of Linux operating system on them. Today around 100% of clusters shipped with Linux. Let's talk about the benefits that you as an end user might have from using Linux. First, you can do analysis and development on local desktops or laptops, but when the tasks to solve become more heavy on computations, the operations are typically outsourced from the local Windows or Mac OS system to server. The server itself has no direct display or input methods attached to it. But most importantly, it has much more storage, memory, and compute capacity than your laptop will ever have, and highly likely works with Linux. The second point is that the software on Linux mostly is open source. Open source software offers the most flexibility of any third-party software alternative. Here is why. you obtain vendor independence. You are never locked into a vendor, their costs, their buying structures, or their redistribution terms. The second point here is no contractual limits on deployment. Open source software often has very liberal terms attached to it for deployment. So you have the greatest possible flexibility on platforms, numbers of users, number of processors, or any other scaling factor that could impact the price of proprietary software. Also, source code allows customization. Because you are in possession of the source code, you may also customize software to meet your needs. And if your customization are of value to others, the community may support your modification in future releases. The last bullet I'd like to mention separately. This is third benefit for you as a developer. Participating in open source projects allow you to improve your skills and self-brand. What I mean, it is always a big credit to your resume if you not only present your proficiency in technology, but also you are the contributor of that technology. Okay? So let me here finish the introduction of Linux and open source software. Let's talk about the terminal. Linux provides great terminal, aka command line, aka shell, in particular bash. Using it you can work with files fast and smooth, without graphical interface. Most of the time, developer works with text files, code files, logs, descriptive data, etc. The shell comes with the set of tools that work with such files. So what is the shell? Computers these days have a variety of interfaces for giving them commands, fanciful graphical user interfaces, voice interfaces. These are great for 80% of use cases, but they are often fundamentally restricted in what they allow you to do. You cannot press a button that isn't there, or give a voice command that hasn't been programmed. To take full advantage of the tools your computer provides, we have to go old school and drop down to a textual interface, the shell. Nearly all platforms you can get your hand on has a shell in one form or another, and many of them have several shells for you to choose from. While they may vary in details, at their core they are all roughly the same. They allow you to run programs, give them input, and inspect their output in a semi-structured way. In this lecture we will focus on the born again shell, or bash for short. This is one of the most widely used shells, and its syntax is similar to what you will see in many other shells. So, terminal command are the binary that has a name, for example, vim. To execute it, one might call a name with the list of arguments. So here you can see the commands that help you to navigate through the system. Okay, let's talk about them. With the pwd command you can find your place in the file file system where your current state is. Whoami command that tells you which user you are logged in and the group of that user. cd command let you change your current directory to another. pushd and popd. This is very helpful commands when you want to go to a directory temporarily. That means you go to the directory and then you want to go back. So to do that, you push in the stack with pushd the directory you want to go, and then with popd you go vice versa. ls command lists all contents of the directory. du, this is common for outputting the disk usage in the current directory. Clear command clears terminal from everything written in it. Also, there are upper level work with files that you can perform with mkdir to create empty folder, touch to create empty file, cpmv. This is useful for copying and moving files. mv is also used for renaming the files. You can call mv from old name to new name to rename the file. rm is used for removing files or directory. Find, it is a tool that performs search in your file system. Here I want to discuss with you the globing. This is concept that allows you to create masks for file names and directories. With globing shortcuts, you can work with files that satisfy the pattern. First, asterisk. It can mask any number of arbitrary characters. For example, head asterisk.txt will output all file headers that match this pattern. That, for example, 1.txt, 2.txt, and something like that. The second shortcut is question mark. It masks one arbitrary character. For example, ls0 ? .txt will output all files in the directory that match this pattern. That means, for example, ls01.txt, 02.txt. Curved braces comes for one character from the specified group or one substring of specified group. For example, if you call rm split in curved braces abcd .txt, that will remove all files that match these four patterns. The fourth item is straight braces with the range. So it masks one character from the specified range. For example, gzip with such name will create 5 zip files of 5 names in such range. So the next step is to learn how to work with the file contents. Which commands can do this? As we see earlier, the head command, we also have a tail command. These commands are useful for printing the beginning or end of the file or stream. It both have option -n, which specifies how many rows to output. By default 10. Grep. It is very useful command. It is used for filtering the input stream. For example, grep error, very important log.txt, will output all occurrences of string error in this file. It has many options. Some of them I provide you here. All options that command has are available in manual page of that command. To see the manual page of the command, you should use command man, shortcut from manual. The next command is unique. It returns unique elements from the input stream. It works the following way. For example, if you have a file with 4 ones and 3 deuces, it will return 1 1 and 1 deuce. Okay? And if you have the second file with 1 1 2 2 1 1, it returns 1 2 1. So it replaces the sequence of same characters or strings with unique string. The next command is sort. It sorts the input data stream. It has several flags. You can check them in manual. Split command splits the source file into smaller files with specified parameters. It may be useful for parallel processing. For example, if you have a big file, you split it with the split command on smaller files and start processes on each part of the file. tr. This utility is needed for converting text in the input stream. For example, this command replaces all lowercase letters with the corresponding uppercase letters. wc. It is a utility for counting characters, words and strings. For example, with the following command you can count all words in a mybigfile.txt. So, Unix-like operating system also have the following concepts. It is pipes and streams, standard streams. In a terminal there exist 3 standard streams: std-in, std-out and std-error. In general case, program takes input from std-in and outputs results in std-out. If there are some additional warnings or errors, it outputs that information in std-error. For example, command ls-lh in USR folder will output something like on the image. So let's talk about pipes. Data streams can be redirected using a special character pipe. If we do such, then the output of one command becomes the input of the next command. For example, we can do the following sequence of command. Output from first command comes to the second, from the second to the third, from the third to the fourth, and after that we use the special character that redirect the output to a file. So awk command will not output in terminal. It will output to the result.txt. Okay, let's sum up our today's lecture. Today we have discussed the brief history of Linux, which devices use Linux as operating system, and we also know how can we benefit from using it. We've discussed the shell and how it helps us interact with computer. Also, we have a brief introduction to shell commands. We will have a more detailed view on the shell commands on the practical session. So thank you.